All right, hello students, this is Bob Burke, and this is going to be a short presentation or review of a short presentation on numbering systems, data encoding, and file types. The intent here is to introduce to students some data that they may see passing through the system, being stored in the system, or processed in the system, and help them better understand what that data format is and how to handle that data format. Let's get started. Numbering systems and encoding are part of the long list of skills that we're looking to help our students develop as part of the cybersecurity program here. You can see the other parts of the list today will focus in on numbering and numbering formats and encoding. A couple of quick comments. The objective here is to help our students identify the data format. Once they know the format, then they can use tools to convert the data or process the data appropriately. Numbering systems, that's going to be your base 2, your base 8, your base 10 or decimal, base 16, and others that are popular in a system environment. Encoding systems, that's where we take characters, data that's in the system and translate it into characters, human readable characters. We use the ASCII character set or we use the Unicode character set, which is based on ASCII, has everything that ASCII has, plus more characters from international other written languages. Couple of comments on numbering systems. Computers are based on 0 and 1. At its core, a computer is an electrical device based on switches or registers that are either on, 1, or off, 0, zeros and ones. And if you look into memory, you're going to see a bunch of zeros and ones, and that's not human friendly. At the same time, it is also not efficient. It takes a lot of space up. So what we do in the system is we convert that binary data, the zeros and ones, into other number formats that are more efficient for storage and for transmission and easier to understand, human friendly. Character encoding, on the other hand, is when we take that data and that data actually represents a message and we need to translate it into the characters, into the alphanumeric, special characters, punctuation, whatever. And we use different formats to do that. We're going to talk about base 32 and base 64, which is a way to represent binary data in a text format. And we're going to talk about ASCII and Unicode. First, decimal, octal, binary, and hex. Base 2 is binary, and you can see by the table over here, it's zeros and ones. Octal is base 8. You use the character sets 0 through 7. There'll be nothing larger than a 7 in an octal character set. Decimal, we know that, 0 to 9, at least in the first position. And hexadecimal in the first position, we have 0 through 9, A through F. So there are a total of 16 characters. We do want to point out at hex oftentimes has a prefix, a 0 lowercase x, which indicates the number following that prefix is a hexadecimal number. You do not use the 0x as you convert the number. That is just a prefix that is to be stripped off when you do your conversion. Base 32 and base 64. Again, if you have a bunch of binary data in storage, this is a very efficient way to convert it into characters. Base 32 has a 32 character set. Base 64 has a 64 character set. And it's a very efficient way to represent binary data in long strings of data that aren't as long as the binary data. A couple of comments. Base 32, the way you recognize that uses all uppercase alpha, and it uses 3, 4, 5, 6, 7, and 9 digits. So if you see data that's all uppercase, has some alpha in it, and then finally it can have padding, which is the equal sign, padding, and it has an equal sign, that is probably base 32. Okay, go to a decoder, use the decoder to convert it and see if you get a usable message out of it. Base 64, on the other hand, is an expanded character set, not 32, but 64 characters. It uses both upper and lowercase, 0 through 9, the plus sign, the / sign, and it has padding. So the quick takeaway here is if you have a long string of characters with equal signs in it, doesn't always have to have the equal signs, but it has the equal signs in it. That is probably base 32 or base 34. If it's all uppercase, look at base 32. If it's mixed case, look at base 64 to decode. Here is an example of an ASCII table. As we said before, this is all the characters you would see on an English keyboard, and they have assigned numbers. For example, if you look at number 65 decimal, 65 decimal is the uppercase A. So a computer might represent in its core memory 65. And once it gets out into an email, it's going to be translated into an A, and so on. So every character on the keyboard has an associated decimal, hexadecimal, also has a binary, a corresponding numeric value that we can convert to. Okay, and that's an ASCII table. Now, you need not do any of this in your head. There are tools that will quickly convert whatever numeric value you have to the ASCII value, or whatever hexadecimal value you have to the ASCII value, or binary. So use the decoding tools to do quick conversions. I happen to like tools that are from hosted by Rapid Tables, but they're just about all the same. Choose the one you like and Google it, bring it up, input your data, and convert it into your ASCII message. Switching gears quickly, we're going to talk about file types. Data can be moving through the system in files, and we just want to point out that there'll be various types of files coming through, and the quicker you can identify what kind of file, you can then determine what you want to do with it. A readable file is normally an ASCII file, a flat file, a notebook file, or something like that. But you might have image, metadata, hidden files, and so on. I'm not going to spend a lot of time on that, but you Google it, use the tools that are available. Once you know what kind of file it is, there may be certain steps we take. For example, there may be hidden data within an image file, and there are various steps that can be taken to extract that data. I'm going to show an example of metadata. Competitions will frequently have an example of metadata, and metadata is simply additional data describing the core data that's in a package. So if you have a picture, then you have the picture itself. Also wrapped around that is some data as to, you know, where that picture was taken, what camera took it, date, time, location, the exposure that was used, and so on. And if you use a tool like Jeffrey's Image Data Viewer and just upload the picture, the JPG, right into the tool, it will show you a separate, it'll show you the additional data that is wrapped around it. Oftentimes in competition, clues or answers to a competition or a challenge will be found in the metadata. So use the tools, fairly easy to do once you get familiar with them. So we're up to our summary now. We talked about numbering systems. For our quizzes and exams, we want to make sure you understand what the base is for each of the number systems, what characters are used in each of the numbering systems. And we're not going to ask you to do the math, but rather use decoding tools if we're going to translate from a numbering system to an ASCII message or to some other format. We talked about ASCII and Unicode. The takeaway there is ASCII is English, 128 characters. Unicode has all of ASCII in it, plus other characters from other written languages. And then the file types. We talked about the ability to identify what type of file it is, and then use Google and other research resources to find tools or techniques to extract hidden data or data from the file as needed. All right, we are done with the presentation. At the very last page of the presentation, we have some sample problems, some sample data formats. You should be able to look at each one of these and knowing the character sets that are used, determine is it binary, is it octal, is it decimal, is it hexadecimal, is it base 32 or base 34, base 64, excuse me. So I encourage you to take these as an in-class exercise, do these and build up your skill in terms of converting data. With that, that's the end of the presentation. Feel free to email me, text me, or contact me if you have any questions. Thank you. Bye-bye.